There, I haven't put it up. Here's the note. Well, since this is the first meeting the first session of IETF 92, I think it's important that I get this up and you know that if you know about any IPR, you're obligated to disclose it. This goes into the detail. There's been an unbelievable amount of discussion about the content of this page. So I'm just going to leave it up for 5-10 seconds. You can read it for the new improved version here. And if you don't mind, I'm going to work directly from the meeting materials. I think I've got the latest version of everybody's slides up there. We have one RSC since Honolulu, 7471. This has gone through a lot of revisions, a lot of information has been put in as far as guidance of how these metrics are advertised and how often they're flooded. There was a lot of discussion about how they're collected, but that has always been out of scope, but it always kept coming up and how, it doesn't cover the end-to-end solution, but that would actually be an interesting informational graph for somebody to do at some point. This draft, we actually got this draft, should have been published by now, RC 7474. We came to very late in the cycle, actually very late, and we decided amongst the authors that it didn't mesh with the spirit of the key chain draft. Key chain, that's my draft. The key table draft, or key table RFC 7210, I believe the number is. So we edited that section enough that we're going through another working group last fall and IETF last fall. That's going on right now. So if you're at all interested in key tables, that was a product of the CART working group. You should take a look at it. Otherwise, the draft is largely this RFC is largely unchanged. It's actually better to fix it before it's published and with a biz version. So it was good that we did go through the work to edit the draft and all agree on the text. This is on the RFC editor's view. We started out, this was done a lot. There was an auto-config draft OSPF-201503 long time ago. There was this zero-count working group, and it never went all the way to the end. We started out with the HomeNet requirement and started with this draft and continued to work on it, even though due to the absence of a open source OSPF-V3 implementation supporting source best routing. It's not really a candidate on that, but this time we went all the way through to the end, and we have OSPF-V3 auto-config. And there were several, David implemented it, and there were some other implementations. One, you can look in the draft to see the state right now. I think all these are close to working group last fall. The first two are enabling drafts. That's why it's hang on. Yes. Their work we need. There's a lot of drafts dependent on this one. It's prefix link app use. This is the OSPF 2 version. So by enabling, this allows us to take OSPF, extend it on infinitum, by adding TLDs. The only bad thing it's not a bad thing. The only bad thing is you have a separate LSAs for the extensions from the base LSAs. So you always got the chicken and egg. get this working group last fall. We have a few implementations. I know we have at least 3 implementations of this in OSPF. Probably another one's underway, so 4 OSPF V2. We'd like to get this. The other one is this. This is this one that I did really quickly, 4970. That's the OSPF capabilities RFC. It originally was meant to be only protocol capabilities, a single instance of the LSA. I changed it now to make it multi-instance, added one new TLB for capabilities bits so everybody doesn't have to define their own. The current capabilities bits in it, because we were advertising all these capabilities that already existed, we couldn't very well say that you use this to determine whether protocol, to influence protocol operation. So rather than that, the new TLB sets will allow you to influence protocol. The new TLB with the capability that will allow you to influence protocol operation based on whether the bit is set or bit. So I really want to get this in because there's a lot of the drafts that are working with documents are dependent on being able to advertise a variable amount of information that may exceed one instance of the router capabilities TLBs. And finally, I think this advertising principle of administrative tags is a pretty it's a pretty straightforward thing. There's ties to the routing working group manageability draft to be able to identify nodes. One real use case in that draft is being able to identify routers that are eligible to be used as targets for remote. And then we got these. I'm going to have an update on some of these today. I'm not going to say anything about it. The first one, unfortunately or fortunately, it looks like we're going to have multiple ways to do this. I guess that's this having routable addresses, at least in OSPF v3. Not OSPF v2, but OSPF v3 already has a mechanism for routable addresses. In the prefix, they have the LA. OSPF v2 doesn't. And these are ones that we just recently. The first two are to advertise information necessary in support of drafts and other working groups. The first for the MRT, the maximally recurring key trees, which is a working group document in the routing working group, and the second is for the seamless VFD working group. I think they're working on that. The second one I think is progressing fairly quickly. VFD at 1 o'clock. And then we have informational or experimental PGP protocol and the 2-part metric. There's at least one implementation of that. We can discuss that more. I think this one is dependent. One of the reasons I want to get prefix linked activity time. This one is dependent on prefix linked activity, and I guess the others aren't really dependent on the RI or the IETF92-OSPF-20150323-0900, but they're aided by it because the more stuff you put in that one LSA, the more chances you're going to want multiple. And finally, the we never did discuss this. Complete this. I think not just because I know the authors, but I think this is a good draft. Because Egypt, what it does is it allows you to have, the TE, you could put addresses from both address families in the TE. Now somebody might say, well, if you're running dual stack in OSPF anyway, you have to run both OSPF v2 and OSPF v3. That is not completely correct because you can do IPv4 with multiple address families. And additionally, even if you were running the dual stack, why advertise TE in both address families? You could just advertising one. And this is what this does. It says, okay, you're running TV, you're advertising TV in, let's say, OSPF-V2. You just advertise reachable addresses for TE or TE endpoints for engineered LSP in the IPv6 addresses. This is still stalled. I don't know why. Since I'm talking on this and it's fallen into a box so far down on my priority list. I don't know what we'll do with this. I still think it's a good thing. But okay. Like I said, I got these updated. These should go very quickly. Somebody just move that back a little bit. No. You get it down. Back it up a little bit. Ah, you get it forward. Move it forward. Move the space. Okay. So as you know, this is the I talked about prefix link attributes as being an enabling for OSPF that allows you to advertise, do basically anything with OSPF v2 by adding TLG bases to the prefix link attributes. Well, this is a more ambitious draft, OSPF v3, where we actually transition from existing LSAs to ones that are completely identical. And it's been around a while. I'm looking for somebody to implement it. I'm within my company and outside, I'm trying to sign some people up. But here, there hasn't been. We've had lots of great reviews. A lot of people, I think most of the people who need to look at this draft have looked at this draft and commented. The mechanisms are stable. We did add one. I'm going to go through it. One change. Not change, we just changed some bits, definition. I'll talk about that later. And I have had a proposal that I'm not very, I'm ambivalent on it, really kind of reluctant to take it forward because for a lower the bar for initial implementation. I'd like to get working group opinion. So here were the changes. We have the LA. This has always been in the prefix options, which means locally advertised. It means the address is locally advertised. This is what I mean. This is a row address. So in the existing OSPF-V3 specification, RFC 5340, it only dictates usage in shrub area prefix LSAs. Well, what I'd like to do, or what we'd like to do, is extend it to both inter-area prefix LSAs and just extend the applicability of the LSA. And this is, there is a flags field that's been added to ISIS for the prefix link attributes that is similar to what it's called. So we're just allowing the LSA to be used in inter-area prefix LSAs. But this is nice. If you have a loopback address, and you want that loopback address to be a routable address, then you don't have to put a loopback in every area. You can just use the one that's look at the inter-area LSAs as well. And then external LSAs as well. Okay, we're going to do an inter-area LSA. We're not going to do an external one is similar to LA bit, but it was different enough that we need to do bit. And this one is similar, but it's under administrative control. You don't need to set LA bit, whereas today for the LA bit, you don't need to set N bit. It says you should set it if it's /128 or flatter. Whereas this one is under administrative control. The other difference, and this is again from the prefix objectives, is that it will be propagated across area boundaries. So not only your own local addresses, but if somebody else advertises one, propagate it. Okay, here's the thing I was talking about that I'm not really that crazy about. But what we would, since we haven't gotten implemented momentum, what we would do is allow usage of these LSAs, not in full deployments, but only for things or TLVs that you need to use for certain features. And backward compatibility would be the onus of backward compatibility would be on the onus of that feature. And that way you have like a sparse advertising. So in other words, it would be exactly this. It would be using the new LSAs in exactly the same way that they're used with the OSPF exam. So, like for instance, if you want to do a segment routing in OSPF v3, you do it. You only advertise it for the prefixes and links that you did segment routing. Like I said, I'm sort of in a business on this. And the downside is that you miss the main benefit of the extended LSA where you're advertising everything, you don't have to correlate between the base LSAs and the extended LSAs. You just use the extended LSAs for everything. I think the implementation hurdle on this is everybody's nervous about the backward compatibility mechanisms. But all it takes is a couple implementations. And the other thing, I got that wrong. You're going to have to do this to correlate the LSAs, between them. You'd be better off using that, which is somewhat inefficient. And you'd be better off using that to actually extended LSA control. Now I said I would not allow standardization because you couldn't really standardize this based on just less than like a quarter of the specification. So it would allow us to get experience with the new extended LSAs, but it wouldn't allow us to standardize. So as you can tell, I'm not too excited about that one. These are Peter's slides. last fall during IETF 92, IETF 92, but sort of after. I think there might be a bug in the replace the meeting material replaced, right? Because I definitely think I said I was going to go faster. Okay, this is the segment routing. It's been presented a number of times. There's been some changes based on the implementation. There's 3 implementations that are interoperated. Yeah, this was added. This was actually added to the base draft. These are these flags. And if you notice, these flags are very much like the flags we just recently added to the OSPF-V3 appended after the pre-click options. We didn't, in OSPF-V3, we didn't add a separate flag page. We already had a pre-click option. We just tried to make use of the existing protocol mechanisms to attend after. Whereas OSPF-V3, the flag page was added. These are identical to the ones in the ISIS prefix strategies. I mean, other than you have the OSPF terminology of AV. There's, you see that full extended range propagation in terms of data based on implementation. I think that mapping server stuff really complicated. It's there. There was a requirement for it. So yeah, we moved the end flag to parent. This is the flag that says this is the flag that corresponds to the flag that I just talked about, the second flag in the prefix options. This end flag. So this is a router address that is under administrative control. Say whether or not you want to set the node bit for a given prefix state. And it is propagated across areas. So if an ADR generates an inter-area, let's say it'll propagate right, for the summary that it injects. The type 3 LSA that it injects. And again, we're going to look for IETF probably a brief implementation from the experience, not experience, but a report. I don't know if that goes that as a draft or some type of paper where we can consider it. There is something in the segment routing that probably won't get implemented for some time, and that's all the encoding of all the RSPP stuff. And my opinion is go forward with the implementation of the product, and we'll cross that bridge when we come to the resident trying to wait for somebody to implement RSPP-based, or not RSPP, sorry, implementing the traffic engineered LSP encodings. Basically, all the ER stuff from RSPP is also in the draft. And I know we implemented that, but I think that implementation before that hasn't been that.
You mean re-advertising LSPs from other protocols?
Yes. Have you implemented it?
No, I have a draft in spring related to that.
Okay.
Hi, Chris Hobbs, Deutsche Telekom. The choice to leave out the password, the clear test password, might be ill-advised. These are, if it's for me and I would, if the ISIS model, I'll probably complain.
The clear
XPath, years to not.
I think we can take that as input. I'm not an author of this draft, but we had like 20 people working on it, so.
Yeah, we had
I didn't need another author.
No, well, so
I've been involved in the beginning as well.
Yeah, I'm thinking particularly just because recently been dragged into the HomeNet stuff, right? And just thinking about how HomeNet, the autoconf uses a specific clear text password. I don't know. I mean, there could be reasons other than people wanting to use bad security to be able to configure that.
Yes, it's clear text. Okay. I think that's why we are here. We are here for comments, right? So if you have any comments. We also actually had a big discussion on whether to include the clear text or not, and decided not to have it for now.
Yeah, we decided not to put it in the keychain.
Not to.
But I think, now that we got the choice.
Yeah, the choice, yeah.
We could talk to the other authors and talk about putting it in the actual protocol models.
Yes.
The keychain, the fact that we're calling it a key.
Yeah.
It's probably good not to put clear text in the keychain. But.
Yeah, I agree with that. I mean, but have some way to configure it.
Yeah, we can, discuss about that. Just add another case in the choice.
Lou Berger, have you given any thought on how your model might be augmented to support TE, or if that even makes sense?
We actually have some basic TE configuration here in the model.
I missed that. Okay.
Yeah, in the configuration part. Yeah, we do have the TE feature.
So I think there's some discussion as to whether or not the TE information is always going to be common with IS to IS, and if that's the case, does it belong in the protocol-specific model, or does it belong somewhere else? And I'm not saying I have an answer. I'm just looking for your opinions on that. Is it better to define basically a container that goes into both OSPF and IS to IS, or just do it separately as part of the other TE models?
There's a lot of legacy here, and if you'll notice for Spring, Stefan and when we talked about it, we said, okay, let's throw this out there. For Spring, we did take that, as you'll see in the Spring working group, the other case of moving it out of the protocols and putting it in a Spring model.
I think there's some other proposals to do that, so I'm really interested in your counter.
You are doing just what you're saying for Spring now. We didn't consider it for TE because it's been around for more than a decade. But
is there any information that you have that is beyond TE interface information?
Right now, at Cisco's implementation, so we have everything. The OSPF part is just configured under OSPF, so that's why we have
Are you
it.
configuring any router information or just interface information, TE information?
In this data model, you mean?
Yes.
Yeah, in this data model, it's just interface information.
So sorry, but as a good example, where is the RFC4203 or whatever it is, GMPLS, SRLG configured? That's not in our model.
No, that's not in our model.
For instance, we did not put that in our model.
So in the TE, generic TE models that are being developed, they already have interface configuration parameters, and it will probably have all the per interface information that you'll carry, and then that could be done both for IS to IS and OSPF. But the router information, if there's TE router information that you want to advertise, I think that's still open. That's not part of what I've seen so far. Again, I don't think we have an answer. I think we have proposals at this stage. So it'll be good to sort of work that out. And the question is do you think that we should do something different for different sort of applications? Do you want Spring to be different, an answer for Spring to be different than the answer you do here for TE? Sometimes it makes sense, sometimes it doesn't. I don't know what the right answer is, so that's a question for the working group.
Yeah.
I guess also for the ISTIS working group.
Yeah, I think we will have to work together with the TE draft in order to make a better draft. Make a
Yeah, my memory isn't serving me. We may not have much more than enabling it on interface.
no, yeah, for the one in our draft, we don't have very
Yeah, I went looking for
much.
SRLG, quite honestly, and I didn't find it, so I'd missed the other. But I do hope we have the same answer for OSPF and ISTIS, though.
Yeah, the problem with TE is the implementation has been there for years, so different vendors have different flavors. It's hard to uniform. Not like Spring is like a new draft, so it's easier to unify it.
Isn't that statement true for any of these Yang models?
Yeah, correct. Okay. So it's hard.
There's one other next step we're trying to do, and I'm going to talk to them, the members of the open config, that have a lot of models too. At least for ISIS and OSPF, the hope is that since we've worked on this for more than a year with, they didn't all fit on it, but there's probably 5 or 6 vendors who have reviewed it and one operator. So hopefully we can get them to. I know we don't agree on. I won't say we don't agree. We have different models for some of the names, BGP, for example. But it'd be nice, say, before you take a look at this and tell us what you think for open config. Because I think we got the right answer. Especially once we decide on the protocol versus birth centric, and I think that's going to happen this week. A lot of those people couldn't come because this is parallel that my working group is happening.
Looks like you have clear text.
So I don't know what happened to my PC. Okay, is Uma here? Oh, there you are. Remember the working class, huh?
Hello. Sorry. This is Uma from Ericsson. So I'm going to talk about OSPF operator-defined TLVs for agile service deployment. This has been presented in IETF 91 in Honolulu. The name of the draft earlier incarnation was self-defined TLVs, and we have got a lot of questions that what is self-defined? What is self really means? Is it the user, router, operator? So we renamed the draft as operator-defined TLVs. And I want to present the same thing here. Next slide, please. So why do we need this? We have recently we have seen the draft in OSPF and ISS, node admin tags, which is a great draft, which enables a lot of use cases, and especially one of the use cases service deployment, service auto discovery actually. So you can quickly identify the services in the network. But where it stops, it just identifies the tag. But for a lot of services, apart from the identifier, you need to have the extra information. Let's say, for example, a label. So here, this draft actually basically what it does is it allows operator to configure services and the service attributes in a easy fashion, and that can be given to a controller, centralized controller, where it can take a lot of decisions. So it also enables us enables the operator for example, these policies can be dynamic. For example, a backup service can be installed, or a load balancing instance can be created on the fly. So the attributes corresponding to that then can be flooded and given to the controller easily. And another use case for this is nodes critical information like energy efficiency, and that kind of critical information can be passed to the controller. And how controller use this for this information is out of the scope of this document. Next slide, please. So what it does is it creates a structure for this to advertise this information, which is driven through policy, local policy. What we are requesting in this draft is basically assign a type from ANA registry from the RITLV registry as defined in RFC 4970. And the flooding score depends on the application. It can be link, area, or domain. Next slide, please. So it has sub TLVs, as we see that the container TLV, it has sub TLVs. So it enables operator to pack multiple attributes for one type. Let's say this type here is the operator provision type. There was a discussion last time that some of the types should be reserved. That is, like, it should be allowed for operator some range and some to be for future use. Alia suggested that. So we have to initiate the discussion on that, but we have an offline discussion on that. So the type can be basically in this draft is for per local policy, and it's operator provision type, and it can have multiple attributes or single attribute. The attribute length represents the attribute value, and attribute value is encoded in the network byte order. If multiple fixed length values have to be represented, it should be represented with multiple 2 tuples, or it can have another type. Next slide. So these are the properties. It's much explained better in the draft, but as a summary is, it is totally opaque to OSPF, and so the router may not be supporting it, but still it can transparently pass through this information. It's a deployment specific TLV. And how receiving node communicates to the ODE sub TLVs with the policy manager outside the scope of this memo. Next slide. So there was this last time when we got a few feedback from a couple of folks here, usage of separate instance. So it depends if the information being passed through this TLV by operator is pertaining to the routing, which impacts routing, it can be used in the same routing instance. If it is not correspond to the routing instance, it can be used in a different instance. OSPF transport instance can be used, for example. Next slide. So we want to acknowledge a couple of folks here. Levi from Verizon, he had interesting use cases for this. We're still discussing his use cases and reviewing it. We thank Chris from Juniper for reviewing and giving valuable feedback, and also suggesting a name for this, which is acceptable probably. And for the earlier incarnation of the draft, we thank AC, Les, and Peter for a lot of feedback and offline discussions. So we guess we took a lot of feedback here, and others feel that it's ready for working group adoption. Probably we can ask in the working group, but I would like to take some questions here.
How many people have read it? Any comments? I have one.
Okay.
I don't like the second use case. I think anything that you were going to, any information you're going to send the controller,
Right.
that really should be standardized.
Yeah. So,
For that second, I don't know. Now, what I struggled. I just apologize. I didn't read this again until last night, but I struggled with the use case, and I came up with one. If you have an infrastructure where you can have operators install their applications, if you're just going to do something, what we don't want to do is just push the problem of standardization one layer lower from the TLB to the sub-TLBs. Because then you have people, vendor X advertising one set of TLBs, and vendor Y advertising another. It's not going to work. But if you have some way that you envision an infrastructure where people can install their applications and allow OSPF to flood the data, then it makes sense.
So yeah, I agree with you. This is one of the reason Alia talked about reserving some space in the types which can be future standardization. For example, energy efficiency or some other critical parameter which can be uniformly understood probably. So that's one of the reason we were just contemplating on that. Probably we can take your feedback offline on this. Yeah, definitely.
Yeah, I guess the AC's concern is sort of the general concern of, okay, you've sort of opened up this little hole, but you can actually potentially drive a truck through this hole, and it's now a non-standardized truck. And so this is useful for, I see reasonable use cases, but it's perhaps in the draft you should address the concerns about it being a truck-sized hole and what the appropriate uses of this hole are, as opposed to sort of leaving it open to the imagination.
Yeah, definitely I agree with Chris, and this is the same point basically. So we have to reserve some of the types and the subtypes basically, so that we can in future somebody can define a parameter which is acceptable and which can be enhanced, so that each node can understand the same thing and can have interoperation basically.
Okay, so we'll talk about whether or not we want to adopt this or adopt it. And I think that's a good point about, limiting use cases. Like the one about the controller, that would also have to be something that's some, an application operator, so you get the interoperability that an operator installed. There's an infrastructure here that's envisioned and doesn't exist yet and is described. So.
Okay.
I'm going to go quick with this. So one thing I realized, now that we have these two enabling mechanisms, OSPF prefix link attributes in OSPF v2 and OSPF v3, we have the extended LSAs, we're able to put tags on any prefix, not just the external prefix, and we can actually put more than one. Now we had use cases for putting prefixes on intra and inter-area prefixes since the 90s, but we haven't had a way to do it, but now we do. So I went to the here's some of the use cases. Identifying prefixes for priority treatment, for example, in many router implementations. The convergence is actually dictated by where in the queue the prefix goes through the whole relative download case, that's one thing. Also equal for redistribution. This is the use case that existed for the longest time, whether or not you want to redistribute a route based on a tag. And if you want to offer a premium service and only protect certain prefixes, you could identify those for LFA or any kind of IPR or not just LFA protection. And I took a lot. I more than read. I looked at 5130 and I looked at this is ISI's admin tag draft, and I actually checked what people had implemented in ISI's and how it's used. So it's just a new sub-TLD for prefixes and links. This just goes through the mechanics. It's pretty simple, all the places you propagating route, or if you're doing setting the tag based on the next hop or something like that, if you have EMC, you could possibly set multiple tags. Or if you were propagating a tag across an area boundary, going from an intra to inter-area route, you could actually have EMC. So you may take more than one of these tags from your constituent routes. Again, you should propagate an area, the tags should be propagated to area boundaries. Generally, the way implementations do this is for the routes that go into the local rib, you keep track of one or more tags, and then those are the things that get propagated. So if you get same with inner area, if you have an NSA translation to an external route by an ADR, you propagate the middle. And again, for area ranges, of course, you're not going to propagate the tag because you can have more than one constituent routes. There's a case at NSA that I think was a mistake, but where they special case this, I'm not going to say anything about that. That's the case. That's the case where in the NSA draft, it says that if you have a range and you have a route that matches the range exactly, it allows the route to not be not be a contributor to the range, but the advertising instead of the range. I think that runs the complexity in NSA. So if somebody wants to do that, they can do that with these tags as well. So normally you configure your tags for ranges, either NSA or area ranges, or for redistribution, you configure redistribution policy set tags. Now the ISIS draft, this was way back 7 years ago, and it was in use more than 7 years ago. Probably it took a good 2 years to standardize the size, so more like 10 years. You take it. There was a 64-bit tag. Nobody's implemented this. Nobody's used it. The use case of carrying BGP extended community is not realistic. Nobody's putting a lot of BGP routes in the IEP. So I left that out. I just moved the 64-bit tag to appendix because I couldn't find one vendor who implemented it for ISIS.
I like 5130 a lot, and I have seen customers using it in a lot of use cases, Ericsson customers. And for your statement where BGP routes into IGP, and for this use case for this is, think about inter-area option C, where BGP need to be redistributed into both LGP and LDP and IGP. So there are some cases. I never see this, but probably there might be some cases.
Okay. Well, yeah, put it to the page list. So has anybody read this draft? Okay, a couple. Well, yeah, we can discuss this on this. I left the 64-bit tag in as an appendix. Sorry, I didn't. So we'll take this list. This is the first time it's been presented. It's really dependent on if these prefix link attributes being, you would have to go forward first. So I'm not in a
Hello? Yeah. Okay. Yeah. This is better. Okay. So today I'm going to talk about OSPF TDZ. So first, going to introduction, and then mostly focus on the extension to OSPF. Next slide. So basically, we just virtualize a cloud into edges fully connected from traffic engineer's point of view. So after we virtualize this cloud, and then we will see just edges of this cloud fully connected from traffic engineer's point of view. So here we have a link. This link will have the maximum bandwidth, which is the path of maximum bandwidth path, the maximum bandwidth of the maximum bandwidth path. So after virtualization, so from on any node outside of this TDZ, we just see this topology, virtualized topology. So for every node inside the TDZ, so it will see the whole topology, the topology inside TDZ and the outside of the nodes and the links. So next page. So there are a couple of ways to virtualize, to make an extension to protocol to virtualize the TDZ from traffic engineer's point of view. So one way is that we just add some TLVs for TDZ into existing traffic engineer LSAs. So here, for OPAC LSA, for TLSA, so we have existing route address TLV, we have link TLV. Here, we just add another TDZ ID TLVs into existing TLSA. So optionally, we may add another TLVs for TDZ. So next page. So for TDZ ID TLV, we just have TDZ IDs within this TLV. So this is already defined in the OSPF TDZ draft. So another one is a TDZ optional TLV. This is also defined in the OSPF TDZ draft. We only introduce another bit, virtualized bit. This is optional. So next page. So with this option, so we just go through details to see when we migrate a cloud to TDZ. So first we configure TDZ within this cloud. So after configuration, we can trigger the distribution of TDZ information. Here, TDZ information, we just add a TDZ ID into existing TLSAs. So each node inside the TDZ will distribute TLSA with this additional TLV. So for any node outside, because this TLV will be ignored because this is new, he doesn't care, he doesn't know, so he just ignored. So from this point of view, so it's okay. But inside TDZ, it will know because he is a TDZ aware. So next page. So after we distribute TDZ information and then we migrate to work as a TDZ for this whole cloud. So the edge node, the edge node will generate TLSAs for virtualize the TDZ, just for virtualize those kind of T links between the edge node to edge node. So this TLSA for virtualized TDZ is just the normal TLSAs. So it will virtualize this link. So this TLSA will distribute to outside. So outside we'll see those kind of edges fully connected with T links. But this one, because we use existing TLSA, so edge out or flush out those LSAs maybe takes time. So only after maybe some time, and then we have clear pictures. Next page. So after some time, maybe half hour, 1 hour, so maximum. So we'll have clear pictures of traffic engineer topology for outside node, and for inside node is okay because he knows the TE. So that's the first option for virtualized TDZ. So next page. So another way is that we use another LSA so to wrap up those TE informations. So we already defined a new type, TDZ LSA type, and here we just introduce another type for TDZ TE LSAs. So this LSA will contain the existing information in the TE LSA, and then we just add one more information, TDZ ID TLV. So this method will be is easily and also very clear. So we'll see details in the next slides to see what happens when we do the migration to the TDZ. Next page. So first we configure the TDZ in this cloud, and then we distribute TDZ information using another LSA. So this TLSA will distribute just within this cloud, because after configuration, those edges will know this TDZ LSA, so it will just not distribute this information to outside. So after distributing this TDZ information, and then we can do the migration. So edge node will originate the TLSAs for virtualize those kind of edge-to-edge TE links. So, and then we can flush out those TLSAs for the link inside TDZ right away. So next page. So after migration, we can almost immediately have a clear picture from outside. Every node outside will see this topology, and then this TDZ is virtualized. So inside the TDZ, we have the whole picture of the network. So next page. So this is the algorithm how to figure out the maximum bandwidth between among the edge routers. So basically, this is just SPF. Find the maximum path from edge to edge. So we just use just change existing SPF to find the maximum bandwidth path, and then that's all among the edge to edges. So next page.
Would you always, just one question on this that I wasn't clear on. Would you take any path, or would you take only the best path?
On any path. This is any path. Yeah. Yeah.
So you would advertise the path with the most bandwidth available as opposed to the path that's the shortest within the TDZ.
Yeah, you're right. Yes.
Okay.
Yes.
That's right.
Yeah. Next page. Yes. Yes. We sell the mic. Yeah, we can sell the mic. You come front. Yeah, we can sell the mic.
Rajan, so my question is on, I think you are trying to advertise T1, T3 outside of your transparent zone, right?
Yeah, just among the edges.
Right. So what is the bandwidth you are going to advertise?
Yeah, that's the bandwidth is we have algorithm to find the maximum bandwidth path from T4 to T3.
But you have multiple links.
Yeah. So for example, on this node, we'll find the maximum bandwidth from T1 to T10, from T1 to T3, and then from T1 to T4.
So that's equal to the smallest link that you have along the path. Like for example, if I have 10 gig here, 100, so maximum bandwidth you are going to advertise is 10 gig.
No, we just search the network. So from here, we search the network, find the maximum bandwidth path. So this is just like we find the shortest path. And then as soon as we find the shortest path, we have the cost for that shortest path. So here, we just find the maximum bandwidth path. So as soon as we find the maximum bandwidth path, then the bandwidth for that maximum bandwidth path is the maximum bandwidth. Yeah, thank you. So, any other questions? We need to stay on the back. Yeah, that one doesn't work.
That one doesn't work. Hi, I'm Hannes with Juniper. Going back one slide to the maximum bandwidth calculation. No, to the illustration. One further to the illustration. Okay, so how does the algorithm here work? When you usually do those kind of abstraction things, usually you go and search for the shortest path tree and then extract the minimum link bandwidth on that shortest path tree. So why didn't you pick that method? Just curious. So but then you're overselling a bit, right? Okay. So you're essentially giving a promise that you cannot really hold when somebody wants to signal a LSP through. And my suggestion would be to be a little bit more on the conservative side here. Thank you.
Hi, Lou Berger, process question. We have, and this may be more for AC or an AD who's sort of in the room, half in the room for the next couple days. You have also a TTZ in for RSVP and Ts. Does it make sense to do these things together? If so, we can do it in Ts and just keep OSPF working group in the loop, or do you want to do it separately? And I have to say, I haven't wrapped my head around this of how it would really work in practice, if it really works in practice. But I think the work has to go together. So the question is, how do you want to run it? And I'm okay with either. So, I mean, I'm really just asking opinion of the chair as well as the author.
Yeah, I think for GMBLS stuff, we've left them in the work because nobody understood it. But nobody wanted to understand all of the applications. For this, though, historically kept the TE signaling in the working group side. Let's get a plan side, right? Yes.
That's fine.
Yeah, so.
Can I respond?
Well, I'm responding, actually. As an AD still, the bits and bytes and the protocol stuff, I think, is fine to have wherever the chairs decide it, and that sounds like OSPF. I am worried about the architectural piece of this, the traffic engineering architectural piece. So some of the questions that Hannes was asking about, how do you actually run that algorithm, and is that the right algorithm? Does it have to be a network-wide thing? What are the policy points here? That stuff, that discussion needs to happen in the T's working group.
Okay, so we should probably, so there's a companion draft that says how you do the computation. Yeah, so we'll discuss. There isn't. It's not.
It covers RSVP. I don't remember it covering computation.
Not complicated. So just the singleness point of view in TE. Yes, the how we set our path and then we consider TTZ.
I thought it also needed, now this is a discussion of why this is better than stitching.
Yeah, good question.
Why, in the draft.
Yeah. So because this one, this is just one, if we have multiple areas, So this is some kind of we can provide an automatic way to set up LSP across the TDZ as some kind of a region. So if we have multiple areas, we need to manually configure, or we use a PCE, and then PCE is some kind of I think is we need more configuration there. Just more configuration, or we can say some kind of communicate. Yeah.
So I think we need more discussion. How many people have read it? Actually, more than
Okay, thank you.
Well, there's much more investment to read this draft than there is added value. I'm trying to understand it. How do you say it? Schreiber?
Take this one.
There's no escape.
Oh yeah.
Good morning, everyone. I'm Shraddha, presenting the OSPF link overload. This is a new draft, 00 version of the draft, submitted lately. We have the stub router advertisement in OSPF, which talks about the router going into maintenance and then moving the traffic around the router that goes for maintenance. So this talks about a similar idea for the overlay networks. Next slide. So we have a typical overlay network diagram here. The CEs will not see the PE routers, they just see it as the overlay network, and OSPF runs on top of the CE to CE Blue 1 to CE Blue 2 link. So the underlying network devices are not visible. So when the underlying network devices go for maintenance, we need a way to, similar to the overload functionality, to move the traffic around the router that goes for maintenance to other links, even before the router goes for maintenance. So we have a way to do that if P1 is going for maintenance. So we have mechanisms wherein P1 can inform C Blue 1 to that it's going for maintenance and then move the traffic away from P1 towards P2. But the similar facility is not available for CE Blue 2. So there's no way to inform CE Blue 2 that P1 is going for maintenance. So CE Blue 2 will continue to send the traffic over the same link. So it's not very easy to move the traffic from the remote end to another link. Go next slide. So if we need to, operators find it very difficult to configure manually on every node, every remote end to divert the traffic when Ps go for maintenance or they go for upgradation. So the motivation is to get an automated way to during maintenance to move the traffic away from the links that go for maintenance. Next slide. Next slide. This is another example. So wherein the overlay networks could be implemented on top of broadcast networks over IRB interface. It's just another use case, another way where how you deploy overlay networks. So the motivation for the draft is ease of maintenance, automated upgradation, and minimize traffic loss, so that when you know the router is going for maintenance, you move the traffic away from the node and then verify everything is fine and then go for maintenance. So the way we want to achieve this is to advertise a link overload TLV in rather sub TLV in extended link opaque LSA. So prefix link attributes gives a way of defining the extended link opaque LSA, wherein you could carry attributes of the link. So there is an extended link TLV. So this link overload TLV would go as a sub TLV of the extended link TLV. So it identifies that the link is in overload state. So the remote end identifies the connecting link, and then it increases the metric of that link to max metric, and then refloods the router LSA. So because the link metric is increased, traffic is diverted away from the overloaded link to alternate link, and then so the overlay link is ready for maintenance. This is a solution for P2P links. Next slide. So the broadcast links, we will not be able to increase the metric to max metric because we just want to divert the traffic that is going towards the overlay link, which is going for maintenance, and not to all of your neighbors. So the way to achieve this is to advertise link overload TLV in extended link opaque LSA, and then DR of the link recognizes the new TLV. It removes the TLV originating router from the list of connected neighbors in the network LSA, and then refloods the network LSA. So, so the traffic is diverted away from that overloaded link, and then it takes the another path. So, and then the overlay link is ready for maintenance. So the sub TLV details. So this TLV is carried in the extended as a sub TLV of extended link TLV. It has the type, length, and the remote IP address. So the remote IP address is needed to identify the link when there are multiple parallel links connecting two nodes, because the extended link TLV just has the link ID and link data. So if there are multiple parallel links, with that information you may not be able to distinguish which exact link is going for maintenance. So we have the remote IP address also along with this. For OSPF v3, I think it's missing in the presentation. So we have a link overload TLV specifically for OSPF v3, which is carried in extended router LSA in the router as a sub TLV of router link TLV. So the format is similar. Only thing you just need the type and length, and you don't need the IP address identifying, because the TLV already defines the forward and the neighbor's interface ID. So questions and comments. Yeah.
So you have a backup path on the same server. Another path.
Yeah, alternate path, yes.
So the intention of the max metric is to cut off that link, cut off that path, whole path. You don't want to use that.
Yes, right. So the reason for max metric is, see, it's easy to set a max metric on this side when P1 goes for maintenance to do it on CE Blue 1. You could have different ways of doing it. But the problem is CE Blue 2 won't come to know that this link is going for maintenance. So that's the reason we are having the new TLV.
So do you see an interoperability issue because the other end of the node should be supporting the CE Blue?
Yes, it's an overlay network. So OSPF is running between CE Blue 1 and CE Blue 2. So CE Blue 2 is supposed to should understand this TLV. So if it does not understand, it simply ignores. So you don't have this mechanism, but there's no looping or anything. But then CE Blue 2 increases the metric and refloods, which everybody understands. So there still won't be any loops in case somebody else behind the network doesn't understand this TLV.
So for this to work, both ends of the nodes
Yes.
need to be implemented.
Yes. Yeah, sure. I think it's there in the draft. Yeah.
And also, is there any capability negotiation between the nodes and parameters that
No, there's no negotiation. I think it may not be required because in case the other side doesn't understand, there's I mean, the feature doesn't work, but there's no adverse effect, right? So.
The reason why I'm saying is the operator who's provisioning this stuff later will not have a power solution at other end of the board because the traffic coming from this track will not have both are
Anybody else? You know, I have another, I have comment. I read this and I looked at it and I read it again. And I think the use cases are valid. It's an admirable goal. But why do you need any new TLD? Why can't you just withdraw the link, set a timer, and after the traffic is diverted, take the link out of service?
So
I mean, I can't see any need for this new machinery to block the link in both directions, when you can just take it out of service. And in fact, that's what you do in the broadcast case. Take it out of service. Rather than having the new TLD.
So generally the operators use it for, they want to be sure that the traffic is diverted, only then want to take the router out for maintenance.
Well, you don't take the router out of service. You just part of the procedure would be just to withdraw the advertisement, and because of the bidirectional check, the traffic gets diverted. You just don't advertise it.
So if you just don't advertise it, then it's similar to just taking it out, right? I mean, why? You still.
You do it gracefully because you don't take the link down right away. You set it on. I mean, we just designed a mechanism like this.
Yes.
Similar, where you want it to have a control. Yeah, I don't see why. And if the operators are worried about it not working, why are they worried any more than any other protocol?
It's very similar to taking the link down, and then when the link goes down anyway, the other end would be informed and then taking them, but that will have transient traffic loss, right?
No.
So.
I mean, it will because of microroutes.
Yeah,
you still have transient traffic loss with this as well.
No, because this will not have transient traffic loss, because even if, because of the delays, even if the other end is still sending the traffic, you have the link up, so you still.
That's what I'm saying. I'm saying you do not bring the link down. You don't bring the path down. You just withdraw. And in the overlay. Yes. Maybe it's because it's an overlay. Is that? This is the mic line now. Yeah, this is the mic line.
Yeah, low angle operator. So you don't know the other path is good, so you don't want to take the link down. You want the traffic to be diverted, and make sure it's diverted before you start using it. So that's one thing you want to make sure. If you take it down and the other path is not available, then you'll have to take it. And that's the sort of thing.
So AC said move the link up. Pretend it was down in the protocol. The protocol removes it as if it went down, so the link is still up. So if there's traffic coming to you, it will still go the proper way. Right? So the link is still up. It's just not the average.
You withdraw. So that's where you got to look at to make sure that the traffic is still have it. It's the only path available. It will. We got to look at the details between.
easier to do that. Okay, have you ever heard of the man circuit? Man circuit. So it's based on the technology. It's just the only difference I can see. Only difference I can see is Macrometric only surveys realize, as opposed to saying you absolute when you take it out of survey.
So, AC.
Precisely the way it's done is that you don't actually know that the advertising. So if the physics is being advertised, if I know that it's being isolated by taking I was running okay, then you still want to use it. You want to use it, you want to use storage percentage traffic, but
Are you thinking
After you confirm that all traffic lights well, I don't know what time. Be another quiet.
So in the in the past there was a reverse metric draft in ISIS, and one of the motivations for that allegedly was you wanted to leave the path as the path of last resort, not to take it down. I don't know if you have the same motivation here.
That would be the effect. You use it if it's the only path.
Has the internet been implemented in different ways? And when we have people testing, sometimes how many years ago? This is a long time ago. I hope they're all fixed by now. Okay, well, let's take this one. Before we do the last,
Thank you.
Blue sheets. I know a lot of people are coming in since they first went around. Who has the blue sheets right now? Where are the blue sheets? I know in particular, I know Eric Gray and signed the blue sheets. You did.
This draft is about advertising encapsulation capability using USDF. This is, okay, next slide please. So the use cases for this is, the two use cases predominantly. First is the incremental deployment use case, where a Spring topology, in the Spring topology, you might have a network where all the nodes are Spring capable, not all Spring capable, and also not all are MPLS capable. For example, for the new deployments where you want to deploy a Spring and a Spring capabilities only on the edge nodes, so then the immediate neighbor will not be Spring capable, so you will not have a label with that labels. So to your next segment will be multiple hops away. So to tunnel this traffic, the remote node, which is Spring capable, can advertise a encapsulation capability and the associated parameters. So the node here can automatically encapsulate the packets and send it to this. So this is basically incremental deployment use case. The same thing can happen for beer routers, where all the nodes are not beer capable, and you want to encapsulate the packets, beer packets, and send it to the node where beer capabilities are there. For non-Spring and MPLS deployments, you have Spring to LDP interoperability case where stitching can be done, but this is for non-MPLS and non-Spring capable nodes. The second case is non-MPLS based remote FA, where once the PQ node is configured, it's a non-MPLS based, obviously. So the node's tunneling capabilities need to be advertised to rest of the network. So the remote node, which is establishing tunnel to the PQ node to deliver the traffic to the eventual destination, can use that tunnel and the associated parameters to dynamically establish this tunnel. Next slide, please. So the ingress of the IP-based tunnel knows which encapsulation types supported by the egress IP node easily, and also the parameters. Next slide. So this draft talks about the encapsulation capability advertisement by the remote nodes, and the types of encapsulation listed are MPLS in IP, MPLS in GRE, MPLS in LTTP, and MPLS in IP and IP in IP recently added. Next slide. So the PQ node non-MPLS case, remote LFA case is brought up by Bruno. So we didn't have the text state in the document, but we want to present it here so that we can get some feedback here. So the documents update need to be done as the RLFA case and the encapsulation type to cover those. So the current draft only talks about encapsulating the MPLS packets, but this can be extended to pure IP cases. So also there are cases where the encapsulation, apart from the encapsulation type from the remote node, you got to advertise the parameters associated to the encapsulation type. For example, IP address used for the encapsulation or a GRE key in some cases. So these also need to be worked out clearly in the draft. So we want to present this early, and we want to get some feedback from the people for now.
How many read this?
This is the information that everybody will listen to and store and process. What good would that do to me as a remote node?
As a remote node, when you receive that information, you have some local configuration, and you know that there's remote node capabilities, and you pick according to the local configuration you pick, or it depends on the, or it may not have local configuration. As purely advertised by the remote node, you establish the tunnel using that type, encapsulation type.
So if I understand the draft correctly, the head end of the tunnel will tell everybody that it can push MPLS into an IP tunnel and use the remote node.
No. The head end of the node will understand from the remote node's advertisement that this is the what I should be doing to successfully deliver to the remote end, actually.
So you are advertising the tunnel to a remote node. You are saying I can deliver an MPLS packet to a remote node X, right?
No. Remote. You are the one who are sending the packets to me, Spring packet to me, okay. And your next hop is not Spring capable. So the remote node, which is the next segment in the Spring, is advertising that I have an MPLS in GRE capability. So I advertise it to you. So you immediately understand that this guy can understand, and you put a tunnel to me and send it encapsulate the packets.
Wouldn't this be more of a policy kind that you can use something like a bring tag saying use these nodes for this, rather than advertising capabilities.
But admin tag doesn't specify what is this. There are various encapsulation possible, right?
We have seen so far a little deployment of tunnel sharding, but I'm just saying it's the same thing, just brought to the IGP level.
Precisely, this is precisely the point. That what's the use of it? I mean, this is the information that everybody listens to, especially in IGP.
So, for example, I'll take up the remote LFA case. Probably it can understand the PQ node. You did all the hard work. You find the PQ node. All the PSpace nodes need to know this PQ node, right? PQ node and encapsulation. Then only you can encapsulate. So by advertising beforehand, you don't know what is the PQ node. So, but PQ node, if advertises that again capable of IP and IP tunnel, so all the PSpace nodes which is establishing tunnel can easily establish the tunnel. That's the use case. That's the simplest use case where I can get you.
The point is that you are trying to specify how to route the packet because of certain capability.
No, you are specifying the remote node capabilities all over, because you don't know who's going to use that in the IGP area.
I still see that if you want to say I am capable of doing something, send it to me and I encapsulate it. You can do this via admin tag. You can say admin tag number 10 can do this, can encapsulate it to admin tag number 12 can encapsulate it to TP.
So, for example, admin tag is the same thing, right? You cannot describe all the things using the admin tags and also the associated parameters, right? Let's say you have a PQ node, have multiple nodes, multiple IP addresses. So it says that IP and IP or GRE, you can associate the parameter with that. Yeah, sure. You can. I can talk to offline probably.
So, Stacy, so I think the kind of shaky part of it now when I'm thinking about it is a situation where there would be not universal deployment of MPLS or Spring, right?
Right.
Right, because if the assumption is that everybody supports, you don't need everybody supports Spring, you don't need this. Right?
Absolutely. This is for.
So that's the question of the use case. Is I think for MPLS, just MPLS alone, I think you need to describe why you need to use it. That's what why.
So there is a draft in Spring, which is the Spring Island connectivity, which describes the use case clearly. So Bruno wants that to expand to non-MPLS cases, non-Spring cases. You want to generalize it a little bit, but we can find text for that actually.
Okay. I mean, I think if it gets accepted by Spring, it makes sense, especially. Yeah, Tom? Everybody sign the blue sheets? So we'll discuss, I mean, will you subscribe to OSPF too?
Well, to be honest, I read the ISS version.
Okay.
Let me just put it this way. It's the same thing.
Yes, it is.
It's the same thing. I read the ISS version.
Okay, well, thanks everybody.
Thank you.
For coming. Again, I just wanted to advertise that we're discussing routing config, the infrastructure which all the protocol and policy, at least the protocol and modules are plugging into in the NetCon working group tomorrow at 9 o'clock. And then again on Thursday at 1 o'clock in the routing, the second session of the routing working group.
This last presentation wasn't on your agenda. Which draft was it?
It was encapsulation.
Oh, okay.
Encapsulation.
Well, we shifted it from somewhere else on the agenda?
What?
Did you shift it from somewhere else on the agenda? The last thing on your agenda on the website is the one with Chandra.
Oh, you know that, yeah. I took the order they were in. Materials.
Okay.
Nobody complained, but until you pointed it out, and I just took them out of it. Yeah. It's on there. There's a caption.
It must not be one of the draft Shindoris. It's probably Bruno's. Okay, thanks.
Thank you.
Yeah, not only did I sign it, but I handed it to Adrian, the other way.
When you said they're going to
When's when did you send Robert? Are you part of that thing too? Yeah, I think it does. I mean, there's only so many ways. There was an exception.